Okay, so we are going to record the lesson for today. And I wanted to, let's just get started so that I can record without any problems. Okay, so Nick and Tavon use different methods to solve the equation 1/2 x plus 2/5 equals 9/10. So what we need to do here is I need to actually look at the both methods. Now, the thing I don't like about Nikki's method is that Nikki has all these fractions everywhere, and it's just a lot of work, right? What I think that is good about Tavon's method is that Tavon cleared the fractions, so that way he didn't have to worry about them at all. So, I'm verbally explaining answer A. Nikki had to deal with fractions, find common denominators. That's a lot of work. Tavon found a common denominator of 2, 5, and 10, and then he only worked with just like whole numbers, so it was a lot easier. Tavon's strategy is better, and we're going to practice that type of work today. So a rational equation has an equal sign, and it also has a fraction with a variable in the denominator. So what I'm going to do is I'm going to solve. And they gave us a definition here that says extraneous solution. It's a solution that makes the value in the denominator equal to 0. So like, I'm going to look and see that right now, before I even solve, if I put a -4 in for my denominator, I'd have somewhat of an issue because I would have a 0 in the denominator, and I can't do that. So here we go. The best way to solve these rational equations is to multiply by the LCM, which is this common denominator, guys. So that means that I'm going to multiply the left x plus 4. It's kind of like x plus 4 over 1. And then the right, x plus 4, which, by the way, would be in parentheses, and I would have to do distributive property. So now, when I have these two here, I can cancel out. 1 equals 2, x plus 4. So I'm going to distribute 2x plus 8, and then I'm just going to go ahead and solve. Okay? -7 equals 2x divided by 2. X equals -7/2, which really is x equals -3 1/2. Okay? Oh, you can't see. I'm sorry. I'm sorry about that. Now, the extraneous solution business would be that I couldn't have a -4. X cannot equal -4. I'm going to do the same thing for this next one. I'm going to multiply by x minus 3. And now, the x minus 3's cancel. I get 1 equals 5x minus 15. Okay? And obviously, this is just easy now, two-step equation. My answers were, it's not going to be a whole number. 16/5, or also I could say 3 1/5, whatever is easier. 3.2. I mean, these are all like the same answers, right? Are you good? So this isn't too difficult. Big deal, big picture here. Multiply by the common denominator. In this case, there only happened to be one denominator, so that was really easy. But, all right. Woohoo! I need to figure out what the common denominator is, which means I need to factor this denominator And it turns out it's x minus 5, x minus 3, which is great. So my LCM is the two parentheses so here's what you're going to do. You're going to multiply the left side by my least common multiple. So basically x minus 5, x minus 3. And on the right side, x minus 5, x minus 3. Okay, now, check this out. In the denominator, the x minus 5 cancels with this x minus 5. There is still an x minus 3 times 1, but I'm not going to really, I'm just doing this because I want to take every step super slow. Then over here, I'm going to use the same, like I could even cross out this line I just made through it and say, now look at this, x over x minus 3. What can I cancel out from the denominator? It's going to be this x minus 3 and this x minus 3, which means I still have an x and an x minus 5 in the numerator. I hope that you're seeing that, like, this x is this x. Okay, obviously that was a poor choice in pen. Right? This x is this x. So whatever denominator was not there that I had to multiply by, that's what I put in my numerator. And honestly, equals 2. So now I've got x minus 3 plus x squared minus 5x equals 2. Rearranging it, getting everything on the left, minus 2. X minus 5 plus x squared minus 5x. X minus 5 plus x squared minus 5x equals 0. Rearrange it so that it's a trinomial. Oh, look at this. 1x minus 5x. 1 minus 5. Negative 4x. Then this negative 5 is my constant at the end. So now I'm going to do that. And 5 and 1, right? But how is it going to work? Well, negative 5, positive 1. So, an extraneous solution. So I have here x equals negative 1 and x equals 5. Well, which of these two numbers, if I plugged into the denominator, would give me a 0? Negative 1? Remember, I can't have the denominator being a 0. Negative 1 minus 5, that'd be negative 6, that'd be okay. How about 5 minus 5? That would be wrong. I cannot use 5. X minus 5 is an extraneous solution. Okay? So the real answer, x equals negative 1. Okay, now, next, look at my denominators. There's only two of them. X minus 2, well, They're the same thing. I'm going to multiply everything by x minus 2. If you want, maybe you like it if I do this next to the 7 instead of putting a giant parentheses around. The whole point is that every single term has to be multiplied by the common denominator, LCM. So these will cancel, and I'll just have 5x. 7x minus 2 plus, those cancel, and all I have is a 10, right? So 5x equals 7x minus 14 plus 10. Solve, go, go, go. Negative 2x equals negative 4. Okay, so this is nice, x equals 2. Let's check for an extraneous solution. That means that I'm going to have 2 minus 2. That would make 0. So 2 is an extraneous solution. Therefore, 3 dots, this equation has no solution. No number will work in this. I cannot solve this. Okay? I just realized that I might have taken this video and the microphone's not working. So we'll see. But I'm going to press stop and find out how I can save this, and I'll hopefully post it on YouTube.